Okay, so last time we started our Pandas class, okay, and we discussed why it is used. It's basically for the data analysis and data exploration. And now Pandas we will be using till end of our class, okay. Whatever sections are left in those, till those sessions, this Pandas will be there. We are not going to leave it, okay. That's why I told this is the most important library. Then we discuss how can we import our Pandas library by using the word import pandas, okay, but I gave an alias known as pd. Then we wrote a file known as titanic.csv, and then we go give some simple analysis, okay. Simple thing, want to explore the first 5 rows or first 10 rows, then we explore bottom rows, okay. Then we saw how to access the individual columns of the data frame, right, and how to access individual rows of that. Everything we witnessed, okay, everything we saw. And also we fetched data, if you go here, from a github account, okay, from somebody's github account. We saw how to read even excel file. We saw that how can we read an excel file inside that, okay. Then we saw how can we read the file from a URL which is having your CSV file, and then we also fetch the data from a website which is having tables available on that website in form of HTML tables. Okay, this is the thing we did, and how can we explore that? Now moving ahead, everyone. The same process. Let me continue, and then we discuss also if you have a difference operator other than the CSV. Okay, for example, at the rate is available, then how can you read the file? Till this point, we have done that. Okay. If you have not done that, actually, honestly speaking, you may find difficulty today if you have not gone through that. Okay, because it is very, very important, and several things we discussed, not a small thing, several things we discussed. So in continuation, let me do one thing. Let me read a file first of all, again, and we will start the same way. So before reading the file, I have to import my library once again, because I have just opened my server. So everything it has forget. For example, if I try to use directly function pd.read, okay, underscore example CSV. Okay, and my file is in the D drive. So file is in the D drive, and the file name is, if I'm correct, sample.csv. Okay. If I execute this, I should get an error, right? It is saying PD is not defined because I have not imported the library currently. In the current session, I have not imported. So whatever was available was the past, it was available in the RAM. When I close down my Jupyter, that has gone from the RAM. So I have to import everything again. Okay. So I'm going to mention import pandas as PD. Okay. Now done. My file has been, my library has been imported. Now we can read this data easily and save the result of that in a variable, suppose TF. Okay, and now we can check this data frame example here. Okay, so this is the data I'm having right now. Very simple data I intentionally picked so that this is a data available in a structure format. And what it is a data frame, because it is having data in terms of rows and columns. This is particularly thing we call as a data frame. Okay, so some data set may be given to you. We'll work on the data set as well, right? Some data set, but your boss may want, okay, I want to add some new columns. Okay, you receive this data set and he said, okay, this is name is given, age is given, gender is given, salary is given, incentives is given. I want to have one more column in which I want to know their marital status. Okay, I want to know their marital status of everyone. I need a new column. The column name should be marital status. And in front of that, Pranay's, what is the Pranay's marital status? Shreya's marital status? Arushi's marital status? Raj marital status? I want to see their name. So how can we create a new column? Very simple. You have to just use your data frame name, whatever data frame name is, that is a DF. Okay, come here, put a square bracket, and within the quote, single quote or double quote, mention the column name that you want. Choose as per your choice. So I mentioned that marital underscore status, suppose. Okay, marital underscore status. Okay, and suppose what value I want to assign. Okay, suppose I want to assign everyone. Your boss is okay. Quickly give me in 1 second. 1 second, I need everyone's marital status. Of course, this is 4. So of course you can go to the 4 files and you can search and tell me, okay, this is marital status of this is this, this is this, this is this, this is this. Okay, but you want to save your time. You don't have time. You're saying I need in 1 minute. Okay, so what you said, okay, how my boss will come to know whether the person is married or not? I will give everyone married. Okay, so you just come here and mention one value, married, like this. You just mention everyone has to be what? Married. So what will happen? Understand? When I will execute, actually a new column will be created whose name will be marital status, and if in front of everyone in every row means you will see married, 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 married. So I'm assigning a constant value right now. Okay. So this is the way. If you want to create a column which should have a constant value, I repeat once again, you want to create a new column which should have a constant value. So that constant value you can directly mention here. Just use your column data frame name, in square bracket your column name, and whatever constant value you want to use, just mention that constant value here. If I execute this, right, and check my DF once again, see, a new column has been created whose name is what? Marital status. Okay. And after the marital status, in front of everything, what is mentioned? Married, 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 married. Because what I passed a constant value. This is the way to add a constant column, the column which should have a constant value. Just use your data frame name, either the square bracket within the double quotes or single quote, put your column name and equals to whatever constant value that you want to put on. I put a constant value that is a string, right? So that string will be repeating here again and again. You can pass a number here. Whatever you want to pass is your choice, right? It's your choice. Whatever you want to pass, any constant you want to pass, you can pass this, right? Similarly, but suppose your boss came to know, okay, fine, married, married, married. How it is possible? Okay, 19 is fine. She might not be married. 23 is fine. She might not be married. 27 may be possible. 32% seems okay, means something like that. Okay, he witness, he sometimes he is able to get out of you, means you able to understand what this data doesn't seem realistic. How can everyone be married? So he's called on you. Okay, what is this rubbish data you have given to you? Okay, now what you want to do? You want to assign them a different value. Okay, this time you want to assign them a different value. So what I can do, understand everyone, again I can bring here, what is my column name? My column name is marital status. So again I mention marital status, and this time instead of constant value I will pass the actual value. Suppose how? I'm using a list, and within list, the first argument I'm passing is for the first row, that is Pranay. Pranay is 32. So I mention example married. Okay. The second one is Shreya. Shreya is 19. Of course, she will be unmarried. Okay. Third one is Arushi, who is 23. So also suppose she is unmarried. Okay. And fourth one is Raj. Suppose 27. He's married. Okay. So you mention this way. So first information will be go to the first row. Second information will go to the second row. Third information will be go to the third row. And fourth information will be go to the fourth row. So if I execute this, okay, and check my DF once again, I have the proper information, right? Pranay, I mentioned married. So yes, it is married. This I mentioned as unmarried. So this is unmarried. Third, I mentioned as unmarried. So this is unmarried. Fourth, I mentioned as a married. So I can mention a married. Okay. So this is the way to assign a different values to every row. Okay, you can pass them as a iterable, any iterable you can use. I use a list here. Within that list, I pass my elements here as a list. This is the best way to pass a variable because list is my iterable. So within that I pass, okay, this should be my first element, this should be my second element, this should be my third element, this should be my fourth element. Right? Yeah. Suppose similarly, if I do here and copy this, okay, instead of the list, I use example a tuple and execute this. See, same thing worked. If I check again, same result is there. Because tuple is also an iterable, but list is also an iterable. Okay, so you can use either of those. List is preferable, you can use list. So any way you want to use, you can use it, right? So you want to assign different values to every row of a column. This is how you can assign. Clear everyone so far? Please tell me.
Yeah, sir.
Right now, see, suppose now your boss says, okay, fine, I get marital status. Now, what is my need is I want to get their total perks that I'm given to everyone. Total money I'm giving. You have mentioned here salary and incentives differently. I want to see their total salary. Okay, I want to see their total salary here. How much money we are paying them. I want those information. That means I want to get a new column this time. So again, you know how to create a new column. You will mention DF within square bracket, within double quotes or single quote. I mention suppose total parks. Total parks. Now how can I do that? Okay, simple. I want to add every row of this individual columns. Salary plus incentive come here. Again 10,000 plus 2,000 come here, 20,000 plus 5,000 come here, 45,000 plus 15,000 come here. Means row by row calculation I want. Whenever I need this, what I can do, I can directly pass my column names. What are my column names? How do we access the column? Using the DF. One column is salary. This is what I want to add. And second column is your incentive. So I mention here incentives. Okay, just small this thing to do. If I execute, okay, you will get a new column whose name will be total perks, and you will see row by row sum of these particular columns. So if I execute this once again and check my DF, see what is my DF? This is total perks. And this what? See, 50,000 plus 10,000 is 60,000. 10,000 plus 2,000 is 12,000. 20,000 plus 5,000 is 25,000. 45,000 plus 15,000 is 60,000. Okay. So suppose you want to generate a new column this time, but that new column should be some combination of already available columns. So yes, you can do that. Okay. Combination of some individual columns which are available, you can do that. Okay. Suppose I create one more column. And suppose for that purpose, I'm telling this because this will be as a part of feature engineering, right? Suppose I'm saying that I need a new column, which should be something, suppose double of this amount, this column, double of this. Okay. So suppose I'm just giving this name to be doubler. Sometime because feature engineering will be needed. So what I want a new column where it should be mentioned that 2 into 5,000, again 2 into 10,000, 2 into 20,000, 2 into 45. So what I'm going to do, I'm going to mention 2 into df of what? Salary. If I execute this, done. If I check my df again, see, I'm getting a new column known as doubler. 50,000 multiplied by 2 is 1 lakh. 10,000 multiplied by 2 is 2 lakh. This multiplied by 20,000 multiplied by 2 is 40,000. 45,000 multiplied by 2 is 90,000. Okay. So what is the purpose? Remember, we may need to do feature engineering in which we will manipulate our columns which are available. Okay. We may need to add extra feature, and that extra feature may be combination of already available columns, or you apply some expression on those individual columns. Okay, individual columns or combination of, say, suppose I want this way, 2 into df of salary plus, okay, whatever you want to mention is your choice. Again, suppose 3 into incentives, I can do that, no problem, like this. Okay, so I will get a new column which will have 2 times df salary plus 3 times this, and that will give me the total result. Okay, so it will go to the every row, come to the first row. 2 into 50 will be 1 lakh plus 3 into 10 is 30,000. So what will happen? 1,30,000. Okay, if I execute this, see the result, everyone. Right? So you can mention any expression that you want to mention. Okay, and this is how we do the feature engineering. We want to generate new information from the existing information that we are doing that time. We're generating new information. Already information was what? Only information earlier was available. This. So we generated new information. What? Salary plus incentive, total bucks, by using the combination of these columns. Right? Earlier we introduced a constant column where we mentioned that this way. Right? We modified even our column. Right? We even introduced a new column which is having combination of other column by using some mathematical expressions. So everything we can do that, and it is important you should understand. So if I include 2 or 3 columns together, write in an expression. Remember how we are going to be computed row by row. Okay, for every row computation will happen. Clear, everyone? So doubt, for any doubt, if even single one, then tell me, everyone. Even single.
So can we use conditional statements in
Yes, yes,
J?
yes, yes, yes. We can use that. I'll tell you that. Don't worry. We can use that. We can use that. Yes.
So
Yeah, yeah.
can you please scroll up?
Yeah, sure. Please.
In case of married, unmarried, if we have number of objects, then how can we do so?
Sorry. Can you repeat once again?
Marital status is there, na sir?
Mm-hmm.
If we have number of objects, means not only 4 objects. If we have number of objects, how can we give like up to this age married and
Got it. That actually you can do. That information may be available somewhere, right? At least it should be available somewhere. From there, you will take the data. Of course, it will be there, na, somewhere. Right? Example, you have there is another file which is having the status of everyone. Example, okay? Not this file, but some other file is there. Example, right? And what you can do actually, you can perform, if you know the DBMS, there is an option known as joins. Have you heard those?
I don't know DBMS, sir.
Okay, which branch you are from?
EC, sir.
EC. Okay, so SQL, have you studied? SQL?
Not yet, sir.
Okay, fine. Actually, if you're planning to make your career in the data science, please learn SQL. It is very important.
Okay.
If you are planning to make, it is important, actually very important. So actually we do have a joins option. You will see that we can include, even this is one data which is available in one data frame, right? You might be having multiple data frames which are available. So without doing anything or specifying something, what we can do, we can actually form joins between the table. So automatically the data of another table we can add it here. Okay, suppose everybody's information is maintained here, this information, but their gender information is available somewhere else. Okay, so what we can do with the help of join, I can bring a new column or multiple new column which can have their corresponding marital status. Otherwise, you have to do some conditional statement. You have to mention, okay, if the person is this, then his status should be this. If person is this, status should be this. If person is this, status should be this. Means somewhere you need to have some data. Otherwise, how will you identify? There is no logic. How can we identify that Pranay is married or not? There should be. This is actually information which is relevant to a specific person only. Like, right or wrong? I'm married
Yeah,
or not, right? I'm married or not, you don't know. This is my choice. Doesn't matter what is my age. It may be possible I don't get married. Okay. It may be possible I get married at the 18 years of age only. Okay. So that information should be available somewhere. Okay. It should be available. Either you can type it manually the way it is. Okay. Or otherwise, if it is available in form of list somewhere, directly you can use this option. If it is available, directly copy from this. If it is available in another table, okay, you can take from that table and you can merge the data of that table into this table. So automatically that column will come here. I'll show you that how can we merge the tables as well. We'll show you that because that is important actually. Okay, so we will have one table here, one table another, one other table. So we may have 3-4 tables available, and we want to bring one data set out of these four tables. So some data is here, some data is other, and you want to create information from this is actually your database, how the databases have been mentioned there. They maintain data in multiple tables. Actually, this is like this. Okay, suppose I mention you, show you something, Google. Okay, and if I show you example, OLTP databases. Okay, let me just show you images. Okay, how they maintain. Any good one I need so that I can show you something like this. Actually, it's very small diagram actually right now we are having, but let me show you a glimpse. Okay, they maintain the record in the different tables. Okay, they maintain the record like in this table, and when you want to run the query, you actually want to bring the data in when you want to bring the data from multiple tables, right? One is this employee table, is this is the C order ID is there is customer ID is there is categories there, this is products table, this is orders table, this is supplier table, right? Different tables are there, but you want to fetch data from suppose multiple tables together. Okay, at that time actually you have to use the joins. Okay, so you may have to use the joins for the same. Okay, but it should be available somewhere. Otherwise, how will we come to know what has to be put in front of Pranay? Getting the point?
yeah, yeah.
Okay, it should be somewhere. Otherwise, how will we come to know? Okay, one way is that if it is available, manually type. But suppose you have 10 lakh rows, you will get crazy. Of course, you cannot do that. Of course, you cannot do that, right? For the same purpose, it should be available somewhere. If it is available somewhere, no problem. Then we can do that. Then we can use it without any problem, right?
Okay.
Because this is just a list. This is what? Just a list. So if you have a list available, no problem. You can directly use the data that you want. Okay. Okay. So let me come here again. Just a second. Background voice is coming. Yeah. So let me move ahead, everyone. What I was talking about, I think we understood how can we combine, means generate new information from the existing information, right? With the help of some expression on the columns or passing some constant values. We just saw that. Okay, now see what is happening. Suppose I created some extra columns. So sometime what will be happening, you will not require all the columns which are available. Okay, this is the data set you received in which you have name column, age column, gender column, salary column, incentive column, marital status column, total perks column, doubler column. Now your voice says, no, do one thing. I don't need this incentive column anymore. No, remove this. This doubler column, I don't want to remove this. Okay, remove those from my data frame. Okay, means drop those. So what we can do, you can mention df dot drop method is there actually. Drop. Okay, which columns you want to drop. Even rows you can also drop, but you remember I want to drop a column. So what I will do, I will put a parenthesis here. Okay, and within the parenthesis I can pass my column. I can pass my column, which column I want to drop. Suppose I want to drop this doubler column, so exact name should be passed. Okay, I just passed here doubler column. Okay, now if I execute this, see, I will get an error. Let me execute this. See, it should be saying not column name not found in index, or whatever name is not found in index. Can you see? Not found in access. But we saw it is here. The doubler is there, but it is not able to recognize. So actually what happens, it is saying doubler not found in access. When we use the drop method, actually, it searches for this information that you mentioned in these indexes 0, 1, 2, and 3. Okay, it searches here in the rows actually. It searches here, okay? And in here we have 0, 1, 2, and 3, not the doubler. That's why it is not able to recognize. So you have to tell actually this drop method, okay, I don't want to search these. Actually, I want to search this. Don't search on this axis, search on this axis. Okay, search on this axis. So we have to mention here what? For comma, axis equals to 1. Okay, axis is equal to 1. The default axis is 0. 0 means it will search here. So you can understand itself. If we use here 0, 1, 2, and 3, it is used to drop the rows. Okay, it is used to drop the rows. If I mention here, suppose 0, so my row will be dropped. Okay, but I want to drop a column for now. Okay, so I want to drop a column for now. So ensure that mention a column name, and within that mention axis is equal to 1. So if I execute this, you can see in this I don't have this doubler column anymore. Can you mention, see everyone?
Yes, sir.
Okay, the doubler column has gone, no longer available. It's not only, but actually what has happened, remember, your original data frame is the way it is. It has not changed. It is still same. The doubler column is there. I intentionally did that. I'll tell you why is the reason. Okay, but I suppose I want to drop multiple columns. I have just used one column. I want to drop multiple columns, so I can copy this same syntax. And what I can do, whenever you want to drop multiple column, use a list here. Okay, and within the list, pass the number name of the column that you want to drop. So doubler column I want to drop, and suppose this incentives column also I want to drop. So you'll mention here those columns in a list. Incentives. Okay, doubler and incentives. Just close this list. Okay, so this time I passed a list of columns which I want to drop. Okay, now if I execute this, and can you see now I don't have any more my incentive column and my total pucks column. Right, everyone? Can you witness, right? See, similarly, what is happening actually? Again, your original column is the way it is. Your original data frame is the way it is, because what is happening? There is one parameter known as in place. If you go inside and read here, see, there is a parameter known as in place. Okay, and it is what equals to false. Means whatever will not happen in place. Means your original data frame will remain untouched. That's why we are mentioning in place equals to false. If you want to make these changes reflect in the original data frame, okay, somehow you want to make these changes reflect in the original data frame, there are two ways. Either you can put here example like this, df is equal to df.prop. Okay, so now this df will point to the object which is having only these particular columns. This is one way. Other way is that I don't want to use this, then I can mention here what? Let me copy this and let me execute the same statement in the next statement. And you have to mention here what in place equals to true. In place equals to true. Okay, but I will execute that later on because I want to show you, first of all, rows can be dropped, how the rows can be dropped. Okay, let me come here. So now suppose this time I want to drop the rows. So df dot drop. Okay, and now see, I know by default axis is what? Axis is 0. Axis means 0 means it will search here. Okay, so directly I can mention these row indexes 0, 1, 2, these I can pass here, right? So I'm mentioning here example 0. 0 is what? This 0. The 0 is available here. So this row will be dropped automatically. This is what I'm doing. I'm dropping the row. Okay, this row will be dropped without any problem. Row will be dropped, and I'm not mentioning my axis is equal to 0. Not because default is there. See, if I go there, check what is the axis. Axis is equal to 0. The default axis is 0 only, right? That's why it will search for the row. Means it will find it. Okay, 0 is here. So now this row will be dropped. Okay, if I mention here example 1. Okay, so it will search. Okay, 1 is here. This second row, the Shreya row will be dropped. If I execute this, see, there is no longer one index and Shreya has gone. Can you notice, everyone? See, earlier Shreya was there. Now Shreya has been gone. You can drop the rows if you want to drop. You saw how to drop the columns. Now you're seeing how to drop the rows as well. Can you see, everyone?
Yes, sir.
Right? So you can drop the rows as well, right? Now let me show you. Again, your original data frame is the way it is. See, if I come here and check my DF, right? Again, Shreya is there because what is happening? Everything is not happening in place. Everything is not happening in place. It is returning, which you can save it somewhere if you want. Okay. But if I place this instruction, in place is equal to true. Understand? Then your original data frame DF will be impacted. See, if I execute this and check my DF, now you won't have those columns. See, we don't have doubler column, we don't have incentives columns. Clear, everyone?
Yes.
Okay, understand what is the role of the same. Now let me come here. Okay, to my data frame. What is my data frame? This is my data frame. No? Now, will we see how we can access the rows? We know how to access the column. If you want to access any particular column, so to access the column, we have seen that already, but we will see access the column. How can we access any particular column? We can access it by mentioning my data frame name, that is df, and within the square bracket name of the column. That's it. Suppose I want to use name column, so just mention name. Your column is available for you as a series. So any column I want to access, I can just df, and within the square bracket, I can pass my column name. But how to access the rows? Access the rows. Okay, see how we can do that. Let me come here. Okay, and let me use something. Here we are getting some index 0, 1, 2, 3. Fine, awesome. Let it be the way it is. Okay, see. So first of all, let me show you the indexes. Okay, so our data frame has an attribute known as index. Okay, data frame is an attribute known as index. Let me execute this. It is showing what? Okay, what is the index in the corresponding data frame right now? It is starting from 0, stopping at 4, at an index step of 1. Remember, we have seen our range function. Almost same. Start from 0 and at 4. 4 means it will always take 1 less than this. So index will be 0, 1, 2, 3. So all regular indexes are there. See, 0, 1, 2, and 3. This is what we are getting. But we want to change these indexes. Right now, what is the index? 0, 1, 2, 3. We can change it as per our requirement. I don't want to give them value 0, 1, 2, 3. I want to give them some other value. So what I can do, see, I can mention here df.index equals to, okay, again, I can use a list or an iterable like a tuple. Okay. And whatever index you want to give. For first row, I want to index A. For second row, I want index B. For third row, I want index C. For fourth row, I want index D. So as per my requirement, I can change the index. Okay. As per my requirement, I can change the index, whatever index I want to give. Okay. Or instead of A, B, C, D, I can give them the number from 1, 2, 3, 4. My choice. Because what it needs is an iterable, right? It needs an iterable. So we can do that. Let me execute first of all. No problem. Let me execute this. See, if I check my DF once again, can you see what is the index now? ABCD, right? So we can change it to the ABCD. Similarly, instead of ABCD, okay, automatically index is coming from 0, 1, 2, 3. I can mention here my range function. Range function is an iterable function, right? I want to start my index from 1, okay, 1, 2, 3, 4, end at 5 at a step of 1. If I execute this, okay, and check my DFC, now my index is 1, 2, 3, 4. The default is given as 0, 1, 2, 3, but I change it to 1, 2, 3, 4. Okay, by using an iterable, because I say that you can use any iterable here. You can use any iterable here. That's why I use an iterable. Remember? So I use an iterable here. Same thing has been passed here. Okay, or suppose I mention here uh, A, B, C, D. Okay, execute this. See, it is not accepting because it is taking as a single parameter. Must be called with a collection of some kind. It needs a collection. Remember that. Collection. Collection are what? So I may mention anything inside. Suppose instead of A, B, C, D, I'm mentioning a list or I'm mentioning a tuple. See this way. A. So this is a list. We have already seen that. Tuple. Let me check it. A, B, C, D. Done. And let me check again. See A, B, C, D back again. Right? So I'm able to use my list. I'm able to use my tuple. I'm able to use my range function. Okay, which can assign them values, and we are able to just say that A, B, C, D. These are what now labels. These are the labels. Okay, now of this every row, this row has a label A, this row has a label B, this row has a label C, this row has a label D. Okay, but suppose I want to remove this, whatever we have done. Okay, I don't want this. So what I can do, I can mention here df dot reset underscore index method. Okay, I just use df.reset.underscore method. Okay, let me execute this and see my index is back 0, 1, 2, 3. The default it was. But remember, in such case, your index that you have set here earlier, A, B, C, D, that will become as a column. Okay, that will become as a new column this time. If I use my df.reset.index, so my original indexes will be back, but whatever column you have set, right, A, B, C, D, that will become as a part of a new column. But we know how to drop the column, right? We know how to drop the column. Let me check df once again. What is my df? See, original is the way it is because it is not happening in place. Let me see. Is there any option of in place? Yeah, it is what? In place is equal to false. It is what? In place is equal to false. That's why your original is untouched. If I make in place is equal to true, then you know what is going to happen. Okay, so same will be impacted there. So remember, with the help of reset index, we can again come back to the original index that was available. But at that time, whatever index you have set, that will become as a part of a new column. But you know how to drop a column. We just saw the column name is index. Okay, so we use df dot drop this column name index and access is equal to 1. So this particular column will be dropped from that. Okay, but it is not happening in place, so the column is it is. Okay, now let me come how to access the rows. We are coming here. Okay, so suppose we have set the label to be A, B, C, D. Okay, this is the label of the rows. So we can access these rows by their label. How? I can mention here, mention df dot loc function, df dot log. Okay, and within a square bracket, pass the label of the row. Whatever is the label of the row. So suppose I want to access first row. So you can type here A and see I will get first row. Name is Pranay, age is 32, gender is M, salary is 50,000, marital status is married, total bucks is 16,000. So this complete row you are getting, see. If I mention df.b, df.log B, so it will get second row, information about second row, share, 19, F, this, everything. See, if I execute this. Shreya, 19F, 10,000, unmarried, and total bucks is 12,000. Okay, and this is the way to access your rows. You can access the rows by using their labels. And if you check this, this is also a series. Your column is a series, even a row is a series. Okay, if I check the type of this, okay, and execute this, see what it is. It is series. So every column, individual column is a series, or individual row is also a series. Okay, individual column is a series, individual row is a series, and when it is a series, you can access them like a list. Okay, example. If I pass here 0, see what I will get. Can you see everyone what I get? Share. Because it is what? See, I'm coming back again. See. Okay. This is having element. First element is your name, that is Shreya. Second element is 19. Third element is F. Fourth element is 10,000. Fifth element is unmarried. This is 12,000. It's like a list. So first element is Shreya. Index will be 0. Second element will be 19. Index will be 1. Third element is F. Index will be 2. Third element, 0, 1. Yes. Fourth element will be 10,000. Index will be 3. This is the fifth element. Index will be 4. So any element you want to access. Okay. What is the name of the element which is having at the location of B? Okay. So I can come here. What is the name? Name is available at the first position. So Python is a 0 index. So I can use 0 here. I will get the name. See, Shreya. If I want age, so age is available at the second index. That means 1. Age 19. What is gender? Gender means it is available third position. That means index is what? 0, 1, and 2. F. So every information you want to access, you can access. So remember, any cell you want to go, take it that way. Okay. I want to take anything from this name column. Yes, I can do that. Anything from any row or any particular value. Yes, I can select that with the help of this. I hope it is fine, everyone. Clear what we can do with this? Okay, so let me copy this and let me show you that as well. Okay, suppose I put here 0, so it will give me the name Shreya, right? Another way of accessing the row is index. Okay, that is known as iloc method. Okay, that method is known as actually the iloc method. See, df dot index location. Okay, df dot index location within the square bracket. I have to pass index. How does the index see? This is the label, but index is same. First element index is 0, second element index is 1, third element index is 2, and fourth element index is 3. So you know the index 0, 1, 2, 3. So suppose I want to access again this row. Shreya 19F 10,009, right? So we should know what is the index of the same 0 and 1. So what I have to mention here? 1 here. I will again get the same record that I was getting earlier. Right? So this is we are accessing by what? Accessing the rows by index. Okay. And this is what we were doing, accessing the rows by level. Okay, level. Any way you want to use it, entirely your choice. You want to access them by their level, or you want to access them by ilog, index location. Anything will work. Any way you want to access the rows, because remember, I repeat once again, what is the index? This is the label A, B, C, D, but the index is the same. First row is 0, second index is 1, third index is 2, fourth element is your, sorry, 0, 1, 2, 3. Okay, whatever name you put doesn't matter here. Index will always remain same. Your label may change, but your index will always remain same. Clear, everyone? Is it fine? Tell me.
Yes.
Okay, let me move ahead. Only one person is answering. Rest, what happened? I think Ashwarya, who is answering the questions? I can hear the voice of one girl.
Sorry,
Sorry, can you repeat once again? I'm not able to see.
Aishwarya, sir.
Okay, okay, Ashwarya. Fine, fine, fine. Okay, done. Rest, everyone is sitting silent. Okay, let me come here. Okay, now let's talk to very interesting thing. Filtering the data frame. Okay, and for the same purpose, let me bring some data set. Okay, df is equal to pd dot read underscore csv, and I'm bringing from my, I think in my directory it should be there. Let me check. I'm not sure. Let me check Titanic dot csv. Let me just check it is there or not. Yeah, let me check the output df dot head, because I want to check just 5 rows. That is there. Perfect. See, now I have some questions which we have to solve. Okay, what are the questions? Question is that this is the data set which is given to you about the passengers who are traveling on the Titanic. Understand the data set. Okay, this is the name of the person. Example: New Harris Brown. Okay, his gender. This was he was male. Age was 22, and siblings or spouse who were traveling with them was 1, and he was having parents or children there on the ship. That is 0. Their information is given. How much fare he paid, that is given. Understand, everyone? In which passenger class he was traveling. Actually, there were 3 passenger class, 1, 2, and 3 in the Titanic. Okay, and whether he survived or not. 0 means he didn't survive. 1 means he survived. Means when the accident happens, 0 means he died. 1 means he survived. This is the data set, which means the information about the around 887 passengers are given here. Okay, so what is this? In which passenger class they were traveling? What was their name? What was their gender? What was their age? They were having siblings or spouse on the board with them or not? They were having parents and children or not? And how much fare they paid? This is given. Okay, and a question is asked from you as a data scientist or a data analyst. Please tell me the name and age of the most aged person on the ship. Okay, this question is given to you. Okay, this data set is given to you, entire data set is given to you. Okay, which has 887 rows. You want to check, see, I can show you that df dot shape, see, 887 rows. So among 887 rows, you have to tell me what is the name and age of the most aged person on the ship. So how do we solve such problems? Just understand, everyone. Okay, so most aged person you need. Okay, so filtering is on the basis of what? Age. Most aged you talk now, most aged. So your filtering is based on the age, and where age is available in this particular column. So first, let me fetch out what is the maximum age. Okay, automatically the thing will come. So how can we fetch what is the maximum age? I can use df. Okay, my column name is age, and on that I can apply a method known as max method. It will tell me in this particular column, in this particular age column, what is the maximum value. Okay, what is the maximum value in this particular column? If I execute this, this is the maximum age, 80. Okay, this is the maximum age, means this can be a question. Tell me what is the maximum age of a person traveling on a ship. So answer is 80. He is having 80 years of age. Okay, otherwise we can directly use a max function as well, the inbuilt function of the max, and within that max I can pass my df age. It will also give me the same result. Okay, same 80. So we are sure that okay, age is 80. Now what we want to do, we want to actually filter this data frame. Okay, filter this data frame only for that person which is age is equal to 80, where age is equal to 80. So actually what I want to do, I want to compare every row with 80. Okay, every row I want to compare with 80. So what I will do, I will mention here df age, because age information is available in the age column only. Okay, I mention here, see properly everyone what I am writing, equals equals because of comparison, equal to what, this, like this. So what it will do, if I execute this, it will compare every row of the age column with this value. It will compare every row, remember every row of the age column with this value. If means 80 value, if it is 80, it will return me true. Otherwise, it will return me false. Okay, for that row. Means for every row, it will compare. Every row will be compared with 80. If that row is equal to 80, it will return me true. Otherwise, it will return me false. So let me execute this and see what I'm seeing. False, 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 false somewhere. Why? Because see, what is the first row with having index 0? What is that? What is the age? 22. So is 22 equals to 80? No, answer is false. 38 equals to 80? No, answer is false. 26 equal to 80? Answer is false. 35 equals to 80? Answer is false. So it is how it is checking. Okay, so it is showing me what result in terms of true and false. There may be somewhere, of course, because we have got the 80s, of course, there will be some answer. Okay, so what it is returning me? True and falses of that particular column. Now, what I can do, understand everyone, let me copy this. What is my data frame name? DF. Okay, within the square bracket, just mention this condition, which is returning true and false, like this. Just mention this condition. So what it will do, understand everyone, see properly what is going to happen. Now this data frame will give me only those rows of the data frame where this condition is getting true. Okay, so every index will be checked, 0, 1, 2, 3, 4, 5, 6, wherever there will be true. Okay, there will be true. Only those rows of the entire data frame will be selected. So if I execute this, see, I am getting just one row. I am getting just one row and verify his age should be 80. Can you see everyone? What is his age? What is his age? His age is 80 years. Okay. Okay. And how I broke it? Just why I broke everything in the parts. Okay. First of all, what I did, I fetch what is the maximum age. This gave me what is the maximum age. Okay. Now I understood. Okay. This is maximum age, and where I can come across that person as a maximum age. So this thing should be compared with what? My age column. So I compared df of age should be equals to df age dot max. So this will return me true only for those rows which is having age equal to 80. Age is equal to 80, right? So that's why you are seeing true and false. Now I pass this condition inside my data frame, square bracket, pass this condition. Now from this data frame, only those rows will be selected where this condition is getting true. That means only there is one person whose name is Mr. Erignon Henry Wilson Burkworth, who was a male, age was 80 years, okay, and fare he paid 30. He was traveling in the passenger class 1, and luckily he didn't die, he survived. Okay, so every of its information is available. But what was the requirement, everyone? What was asked from him? Asked from us. It was asked from us, name and age is needed only. Okay, not other parameters. So what you are seeing right now, it's a data frame actually. Whatever you are seeing right now, it's a complete data frame, like a tabular structure. From this tabular structure, if you want to select a particular column, of course we can do the way we did earlier, right? So what we can do, we can copy this, come here. And again, how do we access the any particular column, everyone? Remember, what is the DF? If we see our DF, this is our entire DF. If I want to access any particular column, what we do? We put a square bracket, and within square bracket, I mention our column name, right? This is done. If you want to access multiple columns, then again, I pass multiple column inside my list, like sex, comma, name, I'm getting sex and name. So any data frames columns I want to access, the same way I can use here. This is what you are getting here. This is just a data frame. So suppose I want to access what? What is needed from us, everyone? Name and age, right? So I can put a square bracket, first square bracket, and within that, one more square bracket because two columns are needed. If only one column is needed, fine. I can mention this way. What? Name. And you can close your square bracket. Done. If I execute this, see only one information, his name. But if I want his age as well, then I have to put one more square bracket and pass the second argument as a list, that is your age. And I can close the second bracket. Okay. So within the square bracket, I have passed a list here. And if I execute this, I'm getting name and age. And this is what the requirement was. Name and age of the most aged person on the ship. And this is what our requirement is. And let me do one thing. Let me copy it here before that so that you can see. Execute like this. This has the original result. From that, I fetch only name and age. Tell me, everyone, is it fine? Right now, suppose your boss says something. Everyone, see properly. That is important. Actually, what I'm going to tell you. Your boss says, please show me the numbers. Okay, how many persons were there on the ship who were above 50 years of age? Okay, tell me how many persons were there who are having more than 50 years of age. How many persons were there who are having more than 50 years of the age on the ship? Requirement is clear, everyone? Okay, please, requirement is this. Tell me the numbers. Numbers of passengers above 50 years of age on the ship. If you understand the logic, please tell me how can we do that? Try at least. Maximum it will be wrong, no problem. Let it be wrong. Come on. Where the age is available, in which come to the data set. Where is the data set? This is the data set and df.head. Right? Where you can get the information about the age? Which column can tell you information about the age? Among all the column, age column, right? Age column. And what is the condition? Remember?
Above 50.
Above 50. Very good. Your requirement is above 50. Very simple requirement is that age should be above 50. Simple requirement. So tell me, what should I mention?
Whether it is greater than or equals to 50.
Now, above 50 we have mentioned, right? Above 50. Above 50 years of age. Come on, try. You are saying right. But we can mention df. No need of if statement here. No need. See, we can mention here df of age means this condition should be greater than what? No, only above me and mention above 50 years.
Okay.
So above 50 will work. So it is, can't you think it is similar to this condition? This condition that we mentioned here. Where this condition? Right or wrong?
Yes, sir.
Right, almost same condition, right? So if I execute this again, I will get true and false. So every row of this age column will be checked for this condition. Okay, so wherever this condition will be satisfied, you will get true, otherwise you will get false. Let me execute this. See, we are seeing true and false. So what I can do, I can pack this condition inside my data frame, square bracket, take this condition and pack inside the square bracket, right? Pack inside the square bracket. So what it will do, okay, it will select only those rows of the data frame where this expression is resulting true. Okay, it will give me only those rows of the data frame where this condition is getting true. Let me execute this. So I'm getting some results, and it is mentioning how many rows are there, everyone. Can you see? 72 rows, and we can see from the result set itself. Can you see the result? What is the age? 54, 58, 55,
Above
56. Above, everyone is above 50. Okay. What is that? So from this also you can answer what is the number of people? 72. But better is that what this is a data frame, right? So on the data frame, we can use an attribute shape. Use that dot shape. How many people are there? 72. And it is what? It is a tuple. So tuple element, I know how to access that. I can put a square bracket. I can put 0. So it is giving me 72 persons are there. There are 72 persons who are having age above than 50. There are 72 travelers, 72 persons on the ship whose age is more than 50 out of 887 persons. Clear? Please tell me.
clear, sir.
Right? Now, next requirement. See everyone. What is the requirement? Your boss says, tell me the number of people. Okay. Who, remember, I'm mentioning the condition. First condition is that who were traveling in passenger class 1. Okay. Second, and means both the conditions should be satisfied. That is better. Let me mention in one condition only. The one who were traveling in the passenger class 1 and survived. Okay. Who were traveling in the passenger class 1 and survived. Both the conditions need to be checked. Who were traveling in the passenger class 1 and survived. This is the condition I need. So first of all, let me do one thing. How many person were traveling in the passenger class 1? Let me break into the parts. Okay. Number of passengers traveling in passenger class 1. Okay. Number of passengers traveling in passenger class 1. Second, number of passengers who survived. Example. Number of passengers who survived. Third, combination of these two. Number of passengers traveling in passenger class 1 who survived. Okay, so three statements are there. First, tell me number of passengers traveling in passenger class 1. Second, number of passengers in all data set who survived. Third, combination of these two, number of passengers who traveling in the passenger class 1 and survived. Only those passengers of the passenger class 1 who actually survived. Tell me those numbers. I think this is very easy. The person who are traveling in the passenger class 1. This is damn easy, right or wrong? Where this information is available about the traveling in P class,
E
right or wrong?
class.
P class, right? So what should I mention? DF
P school.
P
P
class.
class.
Okay, let me just check, ensure that your names are correct. Otherwise, everything will be wrong. Okay, should be equals to 1, right? Everyone,
Yes,
right?
sir.
So what it will be done? It will be checking. Understand, everyone? It will be checking in this column every row. Okay, to be equals to 1. Wherever you will find it equals to 1, you will see true. Otherwise, you will see false. Okay, so if I execute this, see, I'm getting some false, true, false, true, false, true. See, for 0, it is false because it is, sorry, not here. We have to check in other data frame. Let me come here because that is, above 1 is a filtered result, right? So df dot example head, and let me show you top 10 rows. That is more than ample. See, so he was traveling in the passenger class 3. That's why false. He's traveling in passenger class 1. That means true. Again, false. Again, true. So false, true should be there. Can you see? Right? Now tell me, everyone, if I come here and mention this within the square bracket, I mention this condition, then what will happen? What will happen?
The list will come.
Which list? What
True.
that list will be? Only those rows where this condition is
True.
true. Okay, that means only those passengers who are traveling in the passenger class 1, right? Let me execute this. So I get a list. From this, I can come to know there are 216 passengers who are traveling in the passenger class 1. but I want their number, right? So how can I get their number quickly?
Dot shape.
Yes, very good. Dot shape. It gave me, but it is what a tuple. I want the first element of this tuple. So I know how to
Of
access that.
0.
Yes, very good. Square bracket 0. This is the number of passenger traveling in passenger class 1. Awesome, done. Let me come to the second condition. What is the second requirement?
Who are
Number of
survived.
passenger who survived. Okay, this is the one statement that we solved. Just one. Let me copy this. Yeah, this is the condition that we used. Hash, right? And now requirement is what? Number of passengers who survived. Tell me, how will we solve this problem? Come on, everyone. Now you should get the logic. This is available in front of you. How can you get this? Where the survivor information is available?
Survived.
Column, right? Survive column. So what condition should I mention?
D of survived.
DF of survived, sorry, survived should be what? Equals 1,
True.
right? Should be
1.
equals 1, right? So now what will happen? Your every row, okay, every row of this column will be checked. Every row of this column will be checked. Is it equals to 1 or not? So it will return again true and false. Okay, again true and false. If I execute this, see, false, true, false, true, false, true, false, true. Awesome. Now what we can do? We can mention here df of, and within this I can mention this condition. Very good, very good, very good, right? So I can copy this. Now at least I'm happy everyone is participating. Not everyone, but most of the people are participating. Now it's good. Okay, so let me execute this. I'm getting only those people who survived. Okay, now is the number 342. Okay, 342 people are those who survived. Now their shape I want. Okay, so dot shape, done. 342 8, right? Awesome, very good. I want first element. So again,
Shape of 0.
yes, shape of square bracket 0, done. Now last statement. Number of passengers. Your better word. Number of survived passenger of the class 1. That is a better word. Survived passengers of class 1. Number of survived passengers of class 1. So two things need to be checked. First, they should belong to class 1. Second, they should be survived. So two condition, right? So survive condition is this, right, everyone? This is the survive condition. This is one condition, right? And second condition is what? They should belong to class 1, that we have also seen. There is that. Yeah, this condition, right? If I come here, so I have two conditions. One condition is this for the class 1, one condition for survive. Let me pack both this condition in parentheses like this. Okay, two different conditions are there. So let me pack this inside to be on safer side. Okay, and these two conditions should be true at the same time. Okay, two should be true at the same time is, first of all, should be class 1, and second, they should be survived. Both should be true at the same time. Even if one condition fails, that is not satisfied. Both conditions should be satisfied. Passenger class 1 and survive. When both the conditions should be satisfied at the same time, which logical operation is needed, everyone? Remember, AND operation. Right or wrong?
And
AND operation, right? So what I can use an AND operator like this. And if I execute this, again, you will get true and falses. See? Right? Now what I can do? I can pack this information inside what? My DF. Very simple. DF square bracket. Okay, execute this. I got everyone. Can you see? 1111 passenger class 1. That information. And how many such people are? 136. Okay. Now I know that. I want to know the numbers. Awesome. Okay. Dot shape. Okay. And then I can put a square bracket 0. Sorry. Control Z. Square bracket 0. 136 people. Very good. Clear, everyone? Any doubt in this? Now suppose I want to ask you something, okay? A question, last question for the day. Please compare which passenger class people died more. Which passenger class people died more or survived more, whatever you want to call it as, or what was the ratio of saving? Okay, so for passenger class one, the survival ratio is what? How many total passengers were there in the class one? I think we mentioned somewhere. 216, right? Right, everyone? 216. So their survival ratio is what? For passenger class one, what is that? I think 136 means those who survived, who were traveling in the passenger class. And total, how many were boarded there in the passenger class one? I think we have done that already. I think that is 216, right, everyone? 216. So divided by 216. Okay, let me execute this. 62% people survive, right? 62.96% survived. Okay, and same thing I want to check for passenger class 2 and 3. Can we do that, everyone? I think it should take barely a minute, not more than that. Not more than that. For every class we have to do. Tell me. Quickly, within one line we can do. This thing we can do easily. Instead of passenger class 1, what I have to mention, everyone? 2, right or wrong? And here 3. So this will give me survivors, right or wrong, everyone? Tell me. This will give me passenger class 2 survivors. This will give me passenger class 3 survivors.
Yeah, yes.
Right? Without any problem. Similarly, I want to know first of all the total number. Fine, no problem. Let me copy this. In one line I can come across. This is fine. Let me pack this condition here. Okay. And let me, yeah, it is done, I think. Yeah, what is happening? Okay, this parenthesis is not good. Now let me close the parentheses again. I think we are done with this. Let me execute this. Yeah, fine. But what we need, how many such in the passenger class 2? 184. But I want their shape of 0. Total 184 passenger were traveling in the passenger class 2. Awesome, right? How many of them actually survived? Let me execute this. 87 survived, right? What is their survival ratio? 87 divided by 184, 47%. Fine, no issue, right? Let me come here. Same thing, copy this. Now I want to check for passenger class 3. Okay. How many passenger traveling? 487. Survival 119. Let me check their survival ratio. 119 divided by 487. Let me execute this. The survival is 24%. So which class people died more, everyone? This is 24% for passenger class 3. For passenger class 2, it is 47%. For passenger class 1, it is 62%. So which class people died more?
So
Sorry, 1, 2, or 3?
class 1.
No, this is survival. This is
Class
survival,
Oh,
3.
right? Class
class 3,
3.
sir.
Yes, class 3. Class 3 people, right? And remember, if you've seen the Titanic, that was obvious because your passenger class 3 was in the underground. Or not underground, that is in the basement actually. Your passenger class 3 was in the basement. So first of all, water was coming there if you've seen the movie. Okay, that's why those people died more. And as you move up, your stairs were above. So that's why the passenger class 1 was at the topmost. That's why they died less. Okay, and this is how do we do the analysis? Can you filter now everything, everyone? Tell me, can you do any filtering now or not?
Yes.
Okay, I think you should be able to do that, right? Without any problem. You understand the logic. That's why I explained from the very basic. How can we do the filtering and how can we do that, right? You should understand we are using AND operator. We can use OR operator as well like this. Okay, if I use this, see, execute means either belong to the passenger class 2 or survived. Everything will be considered. Okay, or has been. So passenger class 2 and survived. This number will change this time. Can you see? Okay, so when you want, even one condition is satisfied, I'm done with that. Go with the or operation. But our requirement is what? And here. So and you can use and, you can use or, anything you want. It's your choice. Okay, so we'll continue tomorrow, everyone. Is it fine?
Yes, sir.
Okay, okay, everyone. Bye bye. Take care. Bye, everyone. Bye.
Bye, sir.